Greetings. My name is Kyle, and in this module, we'll take a look at programs that run in the background of macOS called LaunchDaemons and LaunchAgents. Have you ever had Finder or the dock crash only to reopen automatically? System processes are kept alive with a library of files supported by a process called LaunchD, and developers can leverage the same functionality with their own LaunchDaemons and agents. You may ask, why do we need to keep an application open when users can just reopen the application when it crashes? LaunchDaemons have a myriad of uses. For example, if I'm an administrator looking to monitor the applications folder for illicit programs, I might create a script that looks for them and, if one is found, reports it to the user. If you're unfamiliar with scripts using if-then and AppleScript, check out the if statements and while loops modules. But maybe I don't want to run this script manually over and over, or create another policy to regularly run the script over the network. That's where LaunchDaemons come in. Let's start by looking at the dock agent by using the go to folder command and navigate to /system/library/launchagents. If we're looking at Finder with columns, we can see right next to LaunchAgents is a LaunchDaemons folder. The primary difference between these two is daemons affect all users on the system equally, while agents affect users individually. The dock is customizable by individual users, so this agent will accommodate each user. Use Quick Look by pressing spacebar to learn more about the program. Agents, like property lists, are made up of key-value pairs. The first key, KeepAlive, contains a dictionary, which contains a list of subkeys related to the top-level KeepAlive key. KeepAlive will run the job as soon as it's loaded and restart it should the job stop for any reason. The subkeys affect KeepAlive in various ways. To learn more about these, you can consult the man page for particular daemons or see the manual pages online. The last thing I'd like to point out is the executable called by the agent specified at the bottom of the list, /system/library/core services/doc.app/contents/macOS/dock. In theory, this agent will restart dock if it ever goes down. We can test this by opening Activity Monitor, searching for dock in the top right, terminating the process with the button in the top left, and selecting Force Quit. The dock will disappear momentarily and resume thanks to the agent keeping it alive. This is all facilitated by a process called LaunchD, the first process loaded when macOS boots. We can view this process in Activity Monitor by viewing all processes and sorting by process ID, or PID. We won't go over the particulars, but if you're interested in how this process works, see the manual page in Terminal by typing man launchd and pressing return. Thanks to system integrity protection, we can't do much with the programs in the systems directory. Third-party developers can place their own agents and daemons in the local library or user libraries to automate processes. For example, computers enrolled with Jamf will have a few files installed in /library. Let's take a look. Navigate to /library/launchdaemons. There are a few daemons in here, and if you're interested in details on all of them, check out the Components Installed on Managed Computers article on Jamf Nation, linked in the resources page of this module. One simple, yet immensely important daemon in this directory is com.jamfsoftware.task.1.plist. Let's use Quick Look to take a peek. At the top, we have the label. This doesn't function as much else than an indicator for what the daemon does. In this case, run a task every 5 minutes. The dock agent we looked at ran a separate program. This daemon, however, runs shell commands right from the program. First, it calls the Jamf binary with /usr/local/jamf/bin/jamf. Below, we can see it uses the policy argument. It also incorporates a 300-second or 5-minute random delay. Below that, we have another pair beginning with StartInterval. This dictates how often the program should run. In this case, 300 seconds, or again, 5 minutes. Finally, this program is specified to run as the root user. Breaking this down, this daemon runs a process every 5 minutes. In this case, the Jamf binary with the policy option, and a random delay seconds of 300, which will check for available policies from the Jamf Pro server this computer is enrolled in. Because this process runs automatically in the background as the root user, users won't see or need to approve of its execution. If we want to change how often this daemon runs, log into the Jamf Pro server, navigate to Settings, Computer Management, and Check-in. Select Edit, and change the frequency. My server is set to check in every 5 minutes, but we could change it to something like 15 if we don't need computers communicating as often. When computers check in next, the daemon's StartInterval key will update, but we can expedite the application of these changes by opening Terminal and typing sudo jamf manage. Enter your administrative password, and we receive feedback that the management framework, including daemons and settings, are installing and updating. Now, if we navigate back to /library/launchdaemons and use quick look on the task 1 plist, we see the StartInterval key has been updated to 900 seconds, or 15 minutes, meaning this computer will run the commands above: Jamf, policy, random delay seconds, every 15 minutes instead of every 5. The benefit here is that there will be less traffic over the network, but computers potentially won't receive policies quite as quickly. This module covered the basics of LaunchDaemon structure on a system and local level. In the next module, we'll create, load, and start our own custom LaunchDaemons and agents. If you're interested in leveraging LaunchD to automate tasks, it's a module worth checking out. Thanks for watching, and we'll see you in the next module.